Alright, welcome everybody to Advent of Code. Today is day number 13 and I figured that in this video I would show you how I solve Advent of Code puzzles. And we just show I'm showing you the entire thing, like from start to end, what I'm doing, what I'm struggling with, what's going well, what's not going well, just to show you a bit of my workflow. And today is day number 13. Let's see what today brings. We are going onto the river. There's a nice bridge. There's a cool forest. But there's a distress signal. Oh no, my handheld device must still not be working. The packets from the distress signal got decoded out of order. We have pairs of packets. Pairs are separated by a blank line. How many pairs of packets are in the right order? For example, packet data consists of lists and integers. Each list starts with a list open thing, ends with a list closed thing, contains 0 or more comma separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. If both values are integers, the lower integer should come first. If both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. Okay, so this looks in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list. If the left list runs out of items first, the values are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the inputs. Exactly one value is an integer, convert the integer to a list, which contains that integer. Okay, let's at least get my puzzle inputs. And add that here. Dots read. We're splitting on /n/n. Let's see what we get. Print left and right. Let me copy paste the examples in here. Compare to the rights. Okay. So now the question is, how do we write like def is in order? Okay. If both values are integers, if the left integer is lower than the right integer, Let me actually, so the first thing we of course need to do is okay, so at least it seems like we're parsing this correctly, or at least we are parsing this. Let's put it like this. We're parsing something. That's good. So that was easy. Contains 0 or more comma-separated values. When comparing two values, the first value is called left and the second value is called right. If both values are integers. Okay. So then we say or left and right. Left value is left.pop, right value is right.pop. So here we check if both values are integers. The lower integer should come first. So we can say if left val is smaller than right val, and I guess continue checking. Okay, so this is true. Great. If both values are lists. Yes, indeed. Compare the first value of each list, then the second value. If the left list runs out of items first, so this is this case, right? So we got 1, compare 1 versus 1, compare 2, 3, 4, and 4. Convert the right type to a list and retry comparison. Compare 2, 3, 4. Compare 2 versus 4. Left side is smaller, so the inputs are in the right order. Okay. So maybe one thing I guess this should return is no, not a arithmetic error, is returns a tuple of can make decision and the decision. So in this case we should say, okay, we can make a decision and the decision is true. here we can also make a decision, but the decision is that it's false. So then we can say comparison, or can make decision is in order with the left and the right. Cool, that at least helps. And then the question is, if not both values are lists, in this case 2, 3, 4 versus 4, let's write it like this: type left, perfect. Can make decision is order, type left, type right. Maybe I should have done this check earlier, because now we have some duplicated code here. Oh, damn. Okay. I can indeed do the parsing over there. What is happening? So line 42. Okay, let me see. Okay, so we got this list, we got this list, all great so far. We can make a decision, it is true. Then we have test number 2, where we have 1, 2, 3, 4, and 1, 4. So then we first pop the left element. Maybe we should do it here. What I mentioned before. So we can immediately do the mixed types. In types left is int. Left is a list and the type right is an int. There we go. Okay, so it's a bit problematic that on the high level I'm getting that we cannot make a decision. It's a bit annoying because it seems so relatively simple. You just have stacks, you pop the start, you compare them. If you you just run them down, right? Oh. So we're comparing 1 to 1, 1 to 1, 3 to 5. Compare 1 to 1. Comparing 1 to 1, comparing 2, 3, 5 to 4. Oh, I know exactly what we're doing wrong. Okay, so we compare 2, 3, 4 to 4. Okay. Oh, damn, I'm dumb. For both values are lists. Okay, so we update this. Comparing 2 to 4. Okay. Then we have one more rule, and that is that things can run out. If the left list runs out of items first, the inputs are in the right order. Okay, so we can say then left for is 0, if the left list runs out of items first, items in the right order. Okay. So if the left list is out of orders, then we can make a decision it's true. The right list, yeah. Let's continue. So now we can take a look at the examples they had. So the first one is that we can make a decision it's in the right order. Second one, it's a decision it's in the right order. We compare 9 versus 8, right side is smaller, we can make a decision inputs are not in the right order. Here in this case we compare 4, 4, 4, 4. The left side ran out of items, so the inputs are in the right order. And that is not what we have here. I think we need to do this one higher. Actually, I think we need to do this one lower because we check while left and right. It's good that I already went 3 down. Okay, now we can at least make a decision everywhere. Yeah, perfect. Inputs are not in the right order. So inputs are in the right order. The right side ran out of items, so inputs are not in the right order. The right side is smaller, so inputs are not in the right order. Okay, what are the indices of the pairs that are already in the right order? The pairs start as 1. Perfect. Can make decision. Decision is in order left, right. If not, can make decision. Raise value error. The sum of these indices, sum in order is 0. That is weird, because I thought we could. I thought we just showed that we could. I thought we definitely just showed that we could make a decision for things. Oh. I already know, because we mute the lists. Then of course you cannot try this trick twice. It is not a good morning. Okay, so here goes nothing. What I always love about Eric is that normally he manages to create test cases which kind of cover everything. So that's always good. Is what Roland said just before something went wrong. I think we have to retry it like this. There we go. Here goes nothing. The right answer. Okay, that's nice. That's good. We are on our way. Now you just need to put all the packets in the right order. Disregard the blank lines in your list of received packets. The stress signal protocol also requires that you include 2 additional divider packets. Oh. So are we sorting the entire list? The stress signal protocol also requires that you include 2 additional divider packets. The result of putting the packets in the correct order is this. Okay, so we also need to include 2 divider packets to the total thing. Afterward, locate the divider packets. To find the decoder key for the stress signal, you need to determine the indices of the 2 divider packets and multiply them together. Okay, that I can do. That I can do. But the only issue I have right now is that the isInOrder function destroys our inputs. But that's at least easy to solve. So So now that we know that we can at least have the things correctly in order is we can make all inputs is a list for pair in pairs. Left right is pair.split on n. E for left, right is E for right. All inputs that append left, all inputs that append right. Perfect. Okay. So now we have a list with all inputs. Let's take back the previous super nice inputs. There we go. All right, and actually we need to enter the dividing packets. Inputs.append. What did we have? We had a double list with 2 and a double list with 4, right? Such a nice divider packet. Oh no, it's 6. List with 6. Okay, so then I would like to do sort, but I do not know how in the Python language. I know you can sort things based on key. I know that you can pass a function to sort. But I currently do not remember the exact documentation there. So I can do two things. Either I look up the documentation, which I think would normally absolutely not be considered cheating, or what I can do is very quickly implement bubble sort. And I think that because it's advent of code, we can create our own bubble sort, which is crazy. Or inputs. Bubble sort the inputs. So now we indeed have this we have this super nice list, but something goes wrong because I don't even see my dividing package anymore. And that's probably not meant to be. What is happening with my inputs that I do change them somehow? Because I wouldn't be very concerned if it wasn't for the fact that my dividing package is gone. And you can clearly see that some packages have been modified here. I thought it would be fun to just quickly write bubble sorts, but it is not that much fun somehow. Here we go, we see this as well. So I guess that is a bit annoying. Okay. So as an update, it now looks like we are at least, because we are now deep copying the whole list, then we are at least not losing values. The only problem I have is that my bubble sorting is wrong, which I just said would be easy. And I think it's because I was skipping one. I guess we could have waited for that, the fact that this is slow. If only there was... Okay. This is also interesting. Let me maybe just restart with the bubble sort. So what we do is sort step in range for the length of all inputs. And then I don't want to do this. I will say, or if it is in order, is in order, then we say, or if it is not in order, or inputs index, or index, then we swap them around. Swap the inputs. Cool. All right. It's kind of funny because I totally expected GitHub CoPilot to have no issue writing a bubble sort. Every student writes a bubble sort. CoPilot learns from what everyone is contributing on GitHub. So everyone who followed a basic computer science class has written a bubble sort algorithm, and I assume has written a correct bubble sort algorithm. Yet we see that it made a mistake. Okay. Do you think I can find two? Okay. To divide it back to the 10th and the 14th for index input one. Div start is div end. If string input is is equal to 2. We have to multiply them together, right? Okay, I think I am reasonably ready. It's just that my bubble sort algorithm is slow, but that is not an issue. All right, that is it for today. How fast did people do this? So people were done after 13 minutes. Crazy. So I spent 41. Let's do a quick evaluation of what I did today. I am not happy that we had to create a bubble sort algorithm, which we then also did wrong because I couldn't remember anymore what the sorting by function is. And that I was maybe too stubborn to just quickly look it up. I am reasonably happy with this, except for that it modifies all the elements, which became a problem when we started to copy things and we had to actually deep copy them. And I didn't remember that immediately. That was not that good. Overall, yeah, I don't know. Would I ship this code? Bah. I would add way more documentation. Please add way more documentation if you commit something like this at work, because it's very unclear. But then again, the problem is also, the problem statement is already, I found it difficult to really interpret what's going on, what's happening, what are all the edge cases. It's hard to contain that in my brain somehow. But then again, it's 6 in the morning. All right, have a nice day. I hope you liked it and see you tomorrow.